Hello once again. In this video, we're going to be rewriting equations using properties of exponents. Let's begin. So before we can use properties of exponents to rewrite some equations, we need to figure out what were the properties of exponents again. You may have forgotten by now, so let's go over a few of the properties. Uh, Now, when we talk about properties of exponents, we're talking about things that are exponents. For example, if you have a 0 as an exponent, we know that that's always going to be 1. Anything to the 0 power is 1. And that's probably the one that we start with most of the time when we talk about properties of exponents. The next thing that we talk about usually is if you have a negative exponent, what do you do? Okay, so for a negative exponent, let's talk about this like we're doing this for the first time. So, for example, here's how I usually explain it. We have 2 cubed, 2 squared, 2 to the first power, 2 to the 0 power, 2 to the negative 1 power. And what do each of these numbers multiply out to? 2 cubed is 2 times 2 times 2, which is 8. 2 squared is 4. Anything to the 1 power is itself. So you can kind of see a pattern starting here, and the pattern makes sense. Each time you're multiplying by 1 fewer 2, so each time we go from this number down here, it's like we're dividing by 2. Alright, and then here, to the 0 power is going to be 1, because I divided by 2. And then when we have a negative exponent, we divide 1 by 2, so we get 1/2, which is just like we took this 2 and we moved it to the other side of the fraction bar. Now it keeps its luggage, like I usually say. I usually say this is a ticket to the other side, and it keeps its luggage, which is the exponent. So for example, 2 to the negative 2 power, that's 1 over 2 squared, which is 1/4, just like I divided 1/2 by 2. Alright, so the next property that you usually see is if you take two bases that are like bases and you multiply them together and they have an exponent, you add the exponents together as your shortcut. So I used to have a class that had a bunch of cheerleaders in it, and so we came up with a cheer as a mnemonic device for this. It's not really much of a cheer, but it went multiply the bases, add the exponents. And once you stop laughing, you can keep listening. Just whatever mnemonic device you want to use to help you remember when you multiply that bases, you have to add those exponents. Now the opposite of that, when you divide like bases, you do the opposite of multiply. It's supposed to be an A. When you divide like bases, you subtract the exponents. You always subtract the bottom one from the top. Now this one we're probably going to use some when rewriting expressions. The one that I'm going to use in this video, and the one that you'll use the most though, is when you have power to a power. So if we have a base raised to an exponent raised to another exponent, okay, you got to multiply those exponents out. So it's a to the n times m. So we're going to use this property in this video as an example, but you can use other ones depending on what equation you're modifying and how you're modifying it. We're going to use this one on a exponential equation. Now, for exponential equations, you have to remember what types of equations you usually see there, which is either a growth or a decay. And so the form for an exponential equation is y equals some number times 1 plus or minus a rate to the time, or x. And you'll see this in different ways. If you're talking about money, you'll see amount is equal to the principal times 1 plus or minus the rate to the time. And this is if t is in years and yearly. Sometimes you do more than one per year, and in that case you would divide r by the number of times per year, which is n, and multiply t by the number of times per year as well. Alright, so let's do an example. So in this example, let's say that we just got a credit card, and the yearly interest rate is 15%. And we want to know, what's the monthly interest rate? So we're looking for the monthly rate. Alright, so if I was looking at this in terms of an equation, it would be A is equal to the principal times 1 plus 0.15 to the t power. Okay, which is the same thing as p times 1.15 to the t power. Now, in order to uh, figure out the rate here, I need to figure out what I'm adding to 1 right here whenever I do this 12 times instead of just once. So if I want to do this 12 times instead of just once, I'm wanting to know out here on the outside 12 times per year instead of just once. And in order to take that 12 out there, that's going to be the same thing as if I raise this to the 1/12th power in here. Because when you multiply, or when you raise an exponent to an exponent, you multiply. So 1/12 times 12 gives me 1, and so it's the exact same thing as I had before. Alright, so now we multiply, or we raise 1.15 to the 1/12th power. So we get the principal times 1.012 to the 12p power. So what's the monthly rate? Well, the monthly rate isn't this entire thing, because if you remember your exponential growth and decay, this whole part in here is called your growth or decay, whichever one it happens to be, factor. The R is the rate. Okay, so we don't need the 1 part there. We just need the 0.012, which is 1.2%. So it's a 1.2% monthly interest rate. Let's do another example. This example came from the released common exam, which this class will be taking at the end of the semester. So this one says the value v of a car can be modeled by the function v of t is equal to 13,000 times 0.82t, where t is the number of years since the car was purchased. To the nearest tenth of a percent, what is the monthly rate of depreciation? Alright, so in this one, we have our amount is equal to the principal, or the starting amount, which was $13,000, times, remember this is 1 minus r here on the inside, to the t power. Now, a lot of people will make the mistake of saying, well, if this is 1 minus the rate, like to find the rate, we subtract it from 1, and we get 0.18. So then we would divide by 12 to find the monthly rate of depreciation. I'm not even going to do that on the screen because it's wrong. It's not going to be just monthly like that because you're multiplying, you're not adding. So dividing by 12 would tell you how much if it was a constant, but this is not being added, it's being multiplied each time. So, by the way, if you did that, you would get choice A. So that is a tricky problem there. So what we have to do is we have to take this 0.82, and since it's currently yearly, we want to do it 12 times per year. Now, if this said what was the quarterly rate of depreciation, we would do it 4 times per year. If it was the biannually, we would do it 2 times per year. They could say daily rate of depreciation if they really wanted to. So just know that this number isn't always going to be 12. Sometimes it will change. So if we want a 12 there, to make sure this is still the same rate, we have to raise 0.82 to the 1/12th power. All right, so 12t stays on the outside. 0.82 to the 1/12th power gives me, let's see, what was that? I think it was 0.9, uh, 0.984 if I round. So it's 0.9835, so it's 0.984 if I round. So I'm trying to remember that, by the way. So if that number's wrong, I apologize. So let's, now this number right here is still 1 minus my rate. Okay, so I need to subtract 1, or this from 1, to get my answer. So I do 1 minus 0.984, and so I get 0.016, or 1.6% as my answer. So these problems can be tricky. You got to realize that, hey, I'm not actually adding, I'm multiplying, so I have to use my properties of exponents to be able to solve them. That's all for this video. If you have any questions, post them in the comments, and hope you have a good one.